Welcome everyone, my name is Daniel Buckley and I will be your instructor for this course. In this course, we are going to learn all about Android and iOS development inside of Unity. We'll learn how to set up our Unity project in order to build apps to our Android or iOS device. We'll also go over a number of different features that you'll find in many mobile games, such as touch inputs, dragging, and resizing the screen or zooming in and out, as you can see here. One of the most important things about developing for mobile inside of Unity is performance. Performance is something you should always keep an eye on when developing, and we'll go over many different techniques using the Unity profiler to see what is happening and what we need to improve. We'll go over batching models, we'll go over baking the scene, we'll go over optimizing canvases, a lot of different aspects that can greatly increase your performance for your mobile game. We'll also go over a number of different scripting optimizations, talking about caching objects, limiting the use of expensive functions, and overall increasing performance within your scripts, as there are many different potholes that people can fall into when creating scripts inside of Unity that are not that well intended for performance. Finally, we'll be going over the Unity particle system, learning how to create particles, and then across 3 lessons creating 3 different particles: the spark, the portal, and the fire particle. Zenva is an online learning academy with over 400,000 students. We feature a wide range of courses for people who are just starting out or for people who just want to learn something new. The courses are also very versatile, allowing you to view them as video format, as text format, and even allow you to download the project files so you can follow along with the instructor. Now, with that all said, let's get started on learning mobile game development inside of Unity. Hey everyone, in this lesson we are going to be going over how to set up Unity for Android or iOS so that you can then create a game and build it to either your Android or iOS device. First of all, I'm here inside of the Unity Hub, and what we need to do is make sure that we actually have the Android or iOS components installed to our version of the Unity editor. So I'm going to click on the Installs button up here to go to where I have all the different versions of the engine that are installed, and I'm going to be using Unity 2019.1. As long as you're using 2019, then building to Android, you don't actually need to download the external Android SDK or anything like that. It's all built into Unity already. So all we need to do is, once you have your version of Unity installed, we need to click on these 3 little dots here and then select Add Component. And what we want to do is we want to either select Android build support and the Android SDK and NDK tools, and this is about 4.8 gigs, and this will install all the stuff we need in order to build to an Android device. Otherwise, if you want to build to an iOS device, then you can just select the iOS build support down here. But for now, in this course, I'm going to be building to an Android device. So I'll be selecting the Android build support and Android SDK and NDK tools, and then I'll just click on Next here. And we can then click on I have read and agreed with the above terms, click Done, and it should then begin to install. Now, inside of Unity, there isn't really that many differences that we'll be doing, depending on if you're building to Android or iOS. It's all relatively the exact same, except for when we're actually building the project. For Android, we're able to just build it directly to our device, whereas with iOS, you do have to build it and then go through and then build it again inside of Xcode. But if you're building to an iOS device, we'll go over how to set up Xcode, how to set that all up, and connect it to your device. Alright, once it's finished installing, we can just check to see if we have all the components added. Yep, and it seems that I have Android build support already installed, or if you've done iOS build support, that will be installed as well. So what we can do now is create a new Unity project. So I'll click on the new button up here. I'm going to enter in this as just mobile course. The Unity version, we want to use that 19.1 as that's where we installed our Android component. And then we can just click Create Project and get inside of the editor. Alright, here we are inside of the Unity editor. Now what we need to do is convert our platform over to either Android or iOS. Now, as you can see in the top of the screen here, it says we're in the PC, Mac, and Linux standalone platform inside of Unity. So to change that, we can go File, Build Settings, and here in the build settings, what we should see now is either the Android or iOS platform here. So I'm just going to select Android and then click on the Switch Platform button. Now, depending on how large your existing project is, this could take some time, but since we are in a brand new project that's empty, it happens almost instantly. So now you can see at the top of the screen, it says Android. In the next lesson, we are going to be going over just setting up the editor a bit. We'll be adding in our folders, importing some assets, and just setting up a little basic scene where we can start going over all the different touch inputs and gestures in future lessons. We'll also go over how to set up some different aspect ratios in the game view to match whatever your device is. So I'll see you all in the next lesson. Alright, welcome back everyone. In this lesson we are just going to be setting up an editor for the course. We'll be importing some assets and we'll just create a basic scene to test stuff out in the future. So first of all, what we're going to do is create a couple new folders here for stuff that we're going to be storing in them. The first one is going to be called materials, and then we are going to create another folder called our prefabs. This is where we're going to be storing all the different prefabs like our particle effects later on in the course. And we'll then create another folder here called scripts. Now, what we're going to do is actually also drag in a bunch of different 3D model assets that we're going to be using in a later lesson to just experiment with baking lights. These can be found on the kenny.nl website. The link will be down in the lesson summaries, or you can choose to just download the course files, and all of the assets, all of the scripts, everything you'll be seeing and creating inside of this course can be found in those for you to download. But for now, we'll just import the Kenny assets here, and these are just basic environmental nature models like trees, rocks, all these bunch of different models that we're going to be using to test out baking in a later lesson. Shouldn't take that long to import. And then what we're going to do afterwards is actually set up our basic scene here. We're just going to add in a basic little cube and just get it ready for the next lesson where we start to implement the touch gestures. So first of all, what we're going to do is we are going to go and right click and go 3D object, cube. I'm going to call this one our ground. I'm going to set the position to 0, 0, 0, and I'm going to set the scale to 10 by 1, by 1 by 10. And this is just going to be our ground platform here. Now, you might notice that it doesn't really look that good, and the lighting isn't really that well done. You can see the shadows are really dark over here, really not even that bright over here, they're more sort of darkish. And to fix this, what we can do is go to our lighting window here. If you don't have this lighting window up, you can go to Window, Rendering, Lighting Settings, and that will open up the lighting window. And what we want to do here is actually click on the auto generate button down here. And what this will do is auto generate our lights, because at the moment we are using real-time lighting. Later on though, we will be changing from real-time lighting over to baked lighting, as baked lighting doesn't require real-time rendering of the lights. It just creates a light map texture that is applied over the scene pretty much. It does take a while though to actually create the baked map. Rather with real-time lighting, it is done on the fly, but it does require quite a lot of quite a good GPU depending on how large your game is. And on mobile devices, you really want to make the performance as best as you can, as you don't always know what sort of mobile device your players will be playing your game on. So we'll be going over that a bit later, but for now we'll just stick to real-time lighting. And I'm actually going to go into the materials folder here and create a new material called ground. I'll apply this to the ground here. I'll set the smoothness down to 0, and for the color I'm just going to set this to a reddish color like so. Let's also have something here that we can click on and just look at. So I'm going to create another 3D object. I'm going to create a sphere, and I'm going to rename this one here to ball. For the position, that will be 0, 1, 0, and I'm also going to create a new material for this ball as well, which I'm going to call ball. I'm going to drag it onto the model, and just like with the ground, set the smoothness to 0, and for the albedo color, I'm just going to set this to a green like that. We can look in the game view, and it doesn't really seem like we're looking at much, so let's actually move the camera. I'm going to put it in a sort of isometric side-on view, so I'm going to set the position here to -10 by 8. For the rotation for the X, it's going to be 45, and 45 on the Y. Let's actually set that Y to probably about we'll set to about 12. And as you can see, we got this side-on sort of isometric top-down view. Now, when working with mobile, there's lots of different sort of screen resolutions and aspect ratios, and even if you're deciding on going portrait or landscape with your mobile game. So what we can do is actually inside of the game window here, we can actually change the aspect ratio and resolution of our game view to just experiment You might be setting up canvases, you might be setting up game objects in different positions that you want to make sure that they are visible on all different sorts of aspect ratios and resolutions. So what we're going to do is go up to where it says free aspect right here, and if we click on this, you'll see that it pops up with a bunch of existing different aspect ratios and resolutions that come when you select the Android or iOS build platform. So what we can do is we can select one of these. For example, I'll just select this one right here, and you see that it doesn't change a lot because the resolution, it's not really that noticeable as the camera does scale to it. But if, for example, you did have UI elements in here, you would notice that since we are at a pretty high resolution, those UI elements would become quite small as they are scaling to the size of the pixels and not the actual world dimensions. So let's change it to something a bit different. We can change it to portrait mode here to experiment how a game will look if it was portrait mode. Or we could go 16:9 landscape. There's a bunch of other ones as well. There's 18:9 landscape for a bit of those longer phones. And there are also other resolutions here as well. You can try different resolutions such as a 720p one. And yeah, you can even create your own aspect ratios and resolutions here in the game view by clicking on this plus down here. You click on that, pop up with this window over here that just allows you to enter in a name for it. We'll just call this our phone res. It can be a fixed resolution, and for the width we could set it to something pretty much whatever you want. We'll just set the width to 2000 and the height to 3000. You'll click OK. You can match this to your phone resolution or the sort of phone resolutions that you want to be targeting, and then it'll pop up here. So we can select that. You can choose a different one, but for now in this lesson we're just going to stick to free aspect as we don't really need to be focusing on specific aspect ratios right now. So in the next lesson what we're going to be doing is setting up the ability to actually touch stuff on the screen, make it so that when we tap on the screen we can detect that, and we can also detect then what we are tapping on the screen. So I'll see you all in the next lesson. Hey everyone, in this lesson we are going to be setting it up so we can actually touch stuff on the screen. We'll be detecting touch inputs, and then we'll be shooting a raycast towards what we touched and interacting with that object in some way. What we're going to be doing with that interaction is actually changing the color of what will be touched to a random new color. So what we're going to do now is go to our scripts folder. I'm going to right click here. I'm going to create a new C# script called color changer. And what I'm going to do is also just attach this to our main camera here, and then we can open up the script inside of Visual Studio. Okay, so to begin we are going to actually just have one function, and that one function is going to be the update function, which gets called every single frame of the game. And this is actually the only function that we're going to be needing and using in this script. So inside of the update function, what do we want to do? So the first thing we want to do in the update function is check, are we touching the screen? So we can go if input to access the actual input class of Unity, which has many things such as keyboard inputs, mouse inputs, and of course touch inputs. So we'll go if input dot touch count. If this touch count is greater than 0, so if there are more than 0 touches on the screen, and the input dot touches. Now input dot touches is a array of all the different touches that are currently on the screen. So to access the first, or if there is only one touch on the screen, we can just access the 0 element, the first element of the array. If that touch dot phase, now there's also a phase for a touch, and there are multiple different phases such as began, moved, stationary, released. So if this touch phase equals touch phase dot began, so if there is more than one touch on the screen and that touch it has just begun, if this is the frame that this touch has just touched the screen, then what we're going to do is create a raycast from where we touched on the screen first of all. So we'll create a new ray here, and this is going to be equal to our camera.main.screenPoint.ray, and the point on the screen we want to create a raycast from is going to be the input.touches, the first touch, dot position. So this is going to create a raycast on the screen from where we touched, and it's just going to be shooting at whatever we are pointing at. Since we are going to be hitting an object and we need to know information about that object, we're also going to create a raycast hit object here, which is going to store all the info of whatever we hit. And finally, down here, we can shoot the raycast by going if physics.raycast. We can enter an array, and then we want to send this out to the hit of pretty much whatever we hit. We want to send it to hit. And so if we shoot that raycast, what we want to first check of all is, did we hit something? So if hit.collider doesn't equal null, if we did hit something, then what we want to do is change this object's mesh renderer color. So I'm going to create a color variable here. I'm just going to call this our new color, and this is just going to be equal to a new color, and we'll just give it a random red, green, and blue values. So I'll just give it a random.range between 0.0 and 1.0, because this color class here, it takes in its RGB and A values not as 0 to 255 as it would be in the editor. It's actually between 0 and 1. So we'll do that. Then actually I'll just copy this random.range here and paste this for the green and blue values. And for the alpha, I'm just going to set this to 1 and end that off like so. So now we have a new random color that can really be anything on the color wheel. And what we want to do now is set this to the object we hit. We want to set it to its mesh renderer. And for that, we can just go hit.collider.getComponent. We want to get the mesh renderer component, which is pretty much the component that renders the mesh, applies the material, and so on. And with this, we want to just access the material variable and access the color of that material and set this to be our new color. So great, that'll all work. But since we're in the editor and not actually on a mobile device, we won't actually be able to test this out. So what we can do is actually also down here create a different version that will actually work on the desktop, work inside the Unity editor. And for this, we're just going to be checking for mouse inputs. So here we'll just go if input.getMouse button down. If the mouse button was 0, which is the left mouse button. So on the frame that we push our left mouse button down, we pretty much want to do exactly the same as we done up here. So I'll just copy this, paste it in here, and I just want to change input.touches to be input.mouse position like so. And something else you can do in Unity is make it so that only certain code is actually ran, or is actually compiled, depending on the platform that you're playing it on. So what we can do is actually, just above this if statement here for the mouse inputs, we can go hashtag if, and then a space, we can go Unity _ editor, and then after this if statement here, we can just go hashtag endif. Now what this does is basically makes it so everything between this hashtag if and this hashtag endif will only be compiled, so the game will only recognize this if we are in the platform of Unity Editor. So once we build this to our mobile device, this code here won't even be looked. It won't even exist really in the final game. It won't be recognized. And this is a great way if you do have something like this, because mouse inputs can also be detected on touch inputs. So this would be quite conflicting if this was included inside of the mobile build. Alright, so with that script ready to go, we can go back to the editor. Wait for that to compile, wait for our last to go. We can press play, and when we select a object, we should be able to change its color. So I'll click on the ball here, and as you can see, it changed. We can click on this over here, we can click on a bunch of different things, and the color will change. So we can unpress play, and actually what I'm going to do is move the camera a bit closer since it is kind of far at the moment. So I'll just move it down like so. And yeah, there we go. So in the next lesson, we are going to be testing this out on our device. We'll be first of all building this to an Android device, and then the lesson after that will be for all you iOS users. We'll be going over how to build this to iOS, how to set it up through Xcode, and have it on your device. So I'll see you all in the next lesson. Hey everyone, and welcome back. In this lesson, we are going to go over how to actually build our game to our Android device. If you are using an iOS device, then the next lesson will go over how to do that on iOS. But for now, how to do it on Android. So, first of all, what we want to do is enable USB debugging on our phone. So let's hop over there and I'll show you how to do that. Okay, so what you want to do is you first of all want to go to your settings on your mobile device. Then you want to scroll right down to the bottom to About Phone. And then in here, we want to click on Software Information. in here, what we want to do then is just tap on our build number here 7 times. So 1, 2, 3, 4, 5, 6, 7. And what this does is we then have to enter in our current pin, and then developer mode has been enabled. So we can go back to our settings, and if we scroll right down to the bottom, you'll see that we now have developer options enabled. We can open that up, and in here what we want to do is scroll down to USB Debugging here. We want to enable that, and what this will allow us to do is connect our device up to our computer, and it'll allow us to build Unity games directly to our mobile and add that as an app. That's pretty much all we have to do on our phone. Now all we need to do is connect our device to our computer and make sure that it is all set up and ready to go. Alright, now that you have your mobile device connected to your computer, what we need to do is just make sure that it is actually set up and ready to go. Make sure that it is connected to your computer, and to do that we can open up our command prompt window, and what we want to type in here is ADB devices, and it should pop up with your device ID here, and that pretty much tells us that our device is connected and ready to go. And we just need to set up a few things before we can actually build to our device. First of all, we need to go up to Edit, Project Settings, and inside of the project settings we just want to go to the Player tab here. First of all, what we can do is enter in a company name here, if you wish. I'm just going to enter in Zenva, and then for the product name, this is what's going to actually appear as the name of the app. So I'm just going to call this one our mobile course. Then we can scroll down and we want to go to resolution and presentation here. You can decide, do you want your app to be allowed portrait mode and landscape, or one or the other. We don't really want portrait mode. We're going to stick to landscape for this course, so I'm just going to disable all of the portrait options right here. And then what we want to do is we want to scroll down to other settings. Now in other settings, what we need to do is set up something known as a package name. Now a package name is a unique name for your package, which basically is the ID. It allows the device and other apps to be able to identify this specific app. And this is the format. You have com, then dot, then your company name, dot, then your product name. Now this isn't strict. They're not going to know if this is really your company name or if this is really your product name. You can really put whatever you want here, but for the company I'm just going to put Zenva, and for the product name I am just going to put mobile course. Now that's all done for that. We can scroll down and everything else seems to be going good. That's all we need. And so we can quit out of the project settings. We can now open up our build settings by going File, Build Settings, and we need to add our open scenes to the scenes and build. Otherwise we won't be able to build, and when we launch the app nothing will appear. So let's click on the Add Open Scenes button to add our scene to the build list. We have Android selected. Now down here where it says Run Device, default device is fine, but if you have multiple connected, you can choose which specific one you want to actually build to. So I'm gonna make sure to select my device right here, and then I can click on the Build and Run button. Inside this folder here, I'm just going to create a new folder called Builds. And inside of this Builds folder, I'm just going to create the name for the APK to be app. This doesn't really matter what you name it as. The name of the app is not dependent on what this is called. So I'm just going to call it app, press save, and it's going to begin to build. So I'll see you all when this is completed and the app is running on my device. Alright, here we are inside of the app. It is launched on my phone, and what I can do now is tap on the things and see if they actually change color. So I'll tap on the ground, and as you can see, it changed color. Tap it again. I can tap on the sphere, and that will change color. So what we're doing here is we are pretty much shooting a raycast at whatever we're tapping on the screen, and whatever object that hits, it is changing it to a random color. So that's all working well and good. In the next lesson, we are going to be actually setting it up for iOS devices. If you don't have an iOS device, you can skip that lesson, and then we'll be moving on to setting up gestures such as dragging and zooming. But at the moment, we don't have those implemented. We'll go over how to implement those and get them working inside of the app. So I'll see you all in the next lesson. Hey everyone, in this lesson I'm going to show you how you can build your mobile app inside of Unity to an iOS device such as an iPhone. So here inside the editor, The first thing we want to do is go to our project settings by clicking on Edit, then Project Settings. And then the Project Settings window should open up. Then we want to go over to the Player tab. Now, the company name and product name aren't important, they're not necessary for you to change, but you can if you wish. So here I'm entering in my company name and the product name as well. Then if we go down to Resolution and Presentation in the little drop down, we can select which sort of orientations we want inside of our app. For the one we're making here, I'm just going to disable portrait modes as we want a landscape only app. Then down in other settings, the thing we do need to edit here is going to be our bundle identifier. This is basically a unique identifier that all apps have, and the format for it is just going to be com.yourcompanyname.theproductname. Now, these don't have to be actually your company name, they can really just be whatever you want, but this is a format that's recommended, and yeah, I'm just going to put my company and product name in like so, and you can do the same for yours. Then we can go File, Build Settings, and the Build Settings window will open up. We want to make sure that we do have our sample scene inside of the scenes list right here. You can just click on Add Open Scenes to add that to the list. And then we want to go down and click on Build. Also make sure that you do have the iOS platform selected and you're switched over to that as well. So then you can click on Build, and then it will ask you to save it to a certain location. I'm just going to save it to the actual mobile course project folder, like so. Now we'll click Save, and it will begin to build the app. Now, the next thing we need to do is actually download an app called Xcode on the App Store. And Xcode is necessary in order to actually build applications to your mobile devices. So just go on the App Store and download Xcode. Then we want to open up our mobile app folder where we built the actual app to. And inside of that, there's a bunch of different files and folders. But all we want to do is open up the unity-iphone.xcode proj. Double click on that, and it should open up in Xcode. Inside of Xcode here, we want to just double click on our Unity-iPhone selection on the left, and it should then open up a bunch of information that we can edit. The first thing we want to do is make sure that our bundle identifier is the exact same one that we have in Unity. It should be the same, but if it's not, you do need to fix that up. And the display name is just what the app icon is going to be called, so you can pretty much make that whatever you want. It doesn't have to be unique like the bundle identifier. Then we need to go to Xcode and Preferences, and this will open up the Preferences window. In here, we want to click on Accounts, and we want to add in a brand new account by clicking on the plus in the bottom left corner of the screen. Here, we want to just select Apple ID and then click Continue. And all we want to do here is just make sure that the information is correct for us, for your Apple account. And then after that, we're all good to go. We do need an Apple ID or a company whenever we are creating an app to our device, so that is why we are doing this right here. We can just close out of this now, and what we want to do is go to the signing drop down and tick automatically manage signing. This just makes it so that we don't have to go through every single different signing thing and enter it in manually. This will just automatically do it for all the options down below. So click enable automatic, and then everything should be filled in. You should see your team name there, and you should see that you're ready to go. To actually build the app to your device, make sure it's first of all plugged in, and then we can just click on the play button in the top left corner of the screen, and that should begin to build the app to your iPhone, and once that is complete, it should then launch on your device. So that's about it. There's of course many more different options that you can change and tweak, but this is just the basics of how to get an app from Unity onto your iOS device. Hey everyone, and welcome back. In this lesson, we are going to be setting up our first gesture for the touch inputs, and this is going to be a drag gesture. This is very common among many mobile games. If you ever have a Battlefield or a RTS sort of map that you will need to move around in by swiping across the screen to move the camera, then this is pretty much what you need. You need a drag gesture to move around the camera, and that is what we are going to be creating today. So first of all, let's go to our scripts folder here, and I'm going to create a new C# script called drag gesture. And this will also work in any sort of camera orientation. You don't need to set the camera at a set angle or anything. This moves the camera relative to itself. So the camera can even be rotating around or anything really, and you'll still be able to move it relative to its forward and left and right directions. So we're going to attach this to the camera here, and then we will open it up inside of Visual Studio, and we can begin to start scripting. Okay, so the first thing we want to do is actually get the camera component, because Just like with our color change script, we are only going to really be using the update function for this, for the whole script pretty much. We just need to check every single frame first of all if we have a touch count of 1. So if we only have one finger on the screen and we are moving that finger, then we will move the camera. So to check if there's only one finger on the screen, we can go if input dot touch count equals 1. So if there is one finger currently on the screen touching the screen, then what we want to do is we need to figure out how has the finger moved. How has the finger moved from one position to another from this current frame, from the previous frame. And the thing about the input.touches array of all the different touches is that they actually give you something known as a delta position. And what this is basically the distance or the direction that the finger has traveled since the last frame. And that is very useful for what we want to do. So what we're going to do is we're going to create a vector3 variable here, and this is going to be called last pos. This is going to be the last position that the finger was on the screen. And this is going to be equal to input.touches. We're going to get the first touch of the finger. Since there's only one finger on the screen, we only need to get the first touch. We're going to get that position of the finger on the screen, and we are going to take away, we're going to subtract the touches 0. We're going to subtract the delta position. So doing this essentially gives us the position of the finger of the previous frame. And with that, we also then want to get the current frame finger position. So we'll create another vector3 right here, and this is going to be called curpos. And this is going to be equal to input.touches 0.position. We just need to get the current position of the finger. Now what we need to do is calculate the direction between these 2 points. Calculate the direction, the magnitude between these 2 points. How far has it moved? What direction is it moving in? And then we can apply that to our position. Now, in order to do that, we don't really want to do this in pixel coordinates, because at the moment, this position and delta position are in terms of not world coordinates, but screen pixel coordinates. So let's just say you moved your finger a centimeter across the screen. If you were to have a mobile device that had a very high resolution screen, then moving that 1 centimeter would be more pixels than if it was on a lower resolution screen. So you kind of see the problem there, where it would move faster depending on the resolution of your screen. And we don't want that. We want it to move the exact same, and we want to move it based on the world inputs. And that will actually make it so that when you move your finger, the screen will actually move pretty much exactly as you move your finger. So if you have your finger on one point and you move it to the right, when your finger moves, that point is still on your finger. That is what we want. So what we need to do is convert these positions into world coordinates. And to do that, we are going to use the camera component's screen to world point function. And what we could do is, if you've ever interacted with the Unity camera before, then you might know that you can access the camera by just going camera.main. That's useful, but what we're doing is we're checking this every single frame and accessing camera.main twice a frame every single time. That is about 100 to 120 times a second that we are then accessing camera.main. And the thing about that is that camera.main is actually a quite expensive function, as behind the scenes what it really is just a find object with tag of main camera. We of course do not want to do that, as we are working with mobile, and performance in mobile is very important. We'll be going over many different scripting optimizations later on, but for now what we want to do is cache the camera variable. So we're going to create a private camera up here. We'll just call this cam. And then in the await function, actually, which gets called right at the start of when the script gets initialized, when the object gets initialized, even before the start function, we want to get the camera. And to do this, we can just go cam equals get component camera. We just want to get the camera component of this object. Great. So we got the camera, and we got our positions. Now what we need to do is calculate the direction between them. So I'll create a vector3 down here. I'll call this dir, and this is going to be equal to cam.screen to world point. So this is converting a screen point into a world point, and we want to get the last pos, and then we want to subtract that by the current pos. So subtract that by the cam.screen to world point of the current pos. And this will give us the direction and the magnitude in terms of world coordinates. And finally, we can apply that to our position of our camera by just going transform.position plus equals dir, just like that. And now what we should do is, if we were to build this to a device, we should now be able to move the camera around using our finger. One thing you might notice though is that if you build it and you try it with this sort of camera setup, you might notice that it doesn't really match the speed. It feels like you might be dragging it a bit too slow. And the reason for that is because we are using a perspective camera. So where you put your finger, it really doesn't know, since the depth is it changes as it goes along. So what we can do is set the projection type to orthographic, which pretty much eliminates depth and just captures the objects as it sees them. And we'll just move the camera up to maybe a 9 or maybe a 11 on the Y, and we'll set the size to about 6. And so what this will do is basically make it so that if we were to drag our finger from, let's just say we have a finger on the sphere here, and we drag it to the left, then the entire camera will move to the right, and our finger will still remain on the sphere over here. If we were to do this with a projection, with a perspective camera, then there might be some issues just simply because we are using a perspective camera capturing depth, and that changes as it goes down further away from the camera. And so dragging and trying to actually track stuff on your finger would require a lot more mathematics, figuring out how far away from the camera is, the angle, stuff like that. But for an orthographic camera, for a drag like this, it works perfectly fine. And even for a perspective camera, it does work, it just doesn't have the exact same effect as you would with an orthographic camera. So I'm going to build the app and try it out to see if it works. And here we are, I've built the app, and now let's actually test out to see if the dragging works. So I can click on the screen and move left and right, and as you can see, it pretty much tracks my finger. I can move it up, down, move it in circles. The tapping on objects to change the color still works as well. And if I hold on to the right hand side of this of the ground here and move it around, you see that it pretty much follows my finger exactly. And that is because we are doing the screen to world function, which pretty much makes it exactly the same on all sorts of devices. It doesn't matter about the resolution, it doesn't matter how fast or how far you move your finger, it'll always move to that point. And so yeah, that's the drag gesture complete. In the next lesson, we are going to be setting up the pinch and zoom. We're going to be setting up the zoom gesture. So you can go like this. You can move your two fingers out to move in, to zoom in, and move them together to zoom out. So I'll see you all in the next lesson. Welcome back everyone. In this lesson, we are going to be creating our zoom gesture. This gesture is pretty much the exact same as you would find on any mobile device. You get your two fingers and you pinch them together to zoom out, and you spread them apart to zoom in. So what we're going to do is we are going to create a new script here called our zoom gesture, and just like with our drag one, we are going to attach this to our main camera. So I'll do that here, and then we can open it up inside of Visual Studio and begin scripting. So the first thing we're going to do is create some variables. And what these are going to be are, first of all, going to be a public float for our zoom rate. And the reason why we need this is because we want to know, alright, how fast do we zoom in and out, dependent on how far we have moved our two fingers. And by default, we will just set this to 0.015 as a float. Alright. And after this, we also need a public vector2, and this is going to be our min-max zoom. So pretty much we don't want to be able to zoom all the way out forever, and we don't want to zoom in too far so that the camera gets inverted. So we want to set a minimum zoom, which for this vector2 here, we'll just set to the x value of the vector2, and the maximum distance away we will set as the y. We could have separate variables, separate float variables for the min and max, but having it as a vector2 where we can just set the values in the same variable, it's much easier that way. Okay, and just like in the last script, we also need to get our camera component, so we'll go private camera cam. And then in the awake function, we want to get our camera. So here we will get the camera by just going cam equals get component camera. Alright, we got that done. Now, just like in the other one again, we are going to be doing all of our calculations inside of the update function. So this gets called every single frame. And what we want to do is we want to check for when the user has two fingers on the screen. So we can go if input.touchCount equals 2. So if there are two fingers currently on the screen, what we want to do first of all is get the touch positions from last frame. We need to know the touch positions from the last frame in order to know how far the fingers have moved across the screen for the current frame. So we'll create a vector3 here to store that position, and this is just going to be called a prev pos, and this will be equal to the input dot touches 0 for the first finger. We want to get that position, and we then want to subtract that finger's delta position, which, if you remember from the previous lesson, is actually how far and in what direction the finger has moved between the two frames, pretty much. So we'll also do the same. Actually, we can just copy this here. We'll do the exact same for the second finger as well. All changes is to B previous pos, and for the touches, we will just get number 1 index, which will be the second element of the touches array. Alright, so we got that. Now what we need to do is we need to get the magnitude of previous and current touches. Now the magnitude is the basically how far have the fingers moved in terms of distance. So first of all, we are going to get the previous magnitude of the two fingers. And the magnitude is basically how far apart are the two fingers. So first of all, we'll get the distance between the two fingers of the previous frame. So we'll go float prev mag, and this is going to be equal to our A previous pos subtracted by our B previous pos, and we want to get the dot magnitude of those two vectors. Then we want to do the exact same but for our current magnitude, and to do this we will just go input dot touches 0 dot position minus the input dot touches 1 dot position. So the distance between the two positions, and to that we'll just get the magnitude as well. Great, so we got our magnitude. Now we need to know the difference. So what is the difference between these two magnitudes? And that difference is what we are going to apply to our camera to zoom it in or out. So for this, we will just go create a float, and this will be called diff, and it's going to be equal to the current magnitude minus the previous magnitude, like so. And what we can do then is we can change the orthographic size. So if we hop back in the editor here, we can change the size of the orthographic camera here, which basically zooms it in and out. And that is how we are going to do our zooming. But what if our camera is perspective? We don't have the orthographic size. Instead, we have something, we got the field of view here. This might be good for what you need, but for us, it's not really that good. It's not the best solution for zooming your camera, because this isn't actually moving the camera. All it's doing is increasing the field of view, and if you need to zoom out a lot, then you're going to have a very wide field of view and stuff will begin to look warped. So instead, what we're going to do for the perspective camera is in the scene view here, you can see that we have this blue arrow, and this is the local Z axis of the camera, the Z position axis, and it's actually pointing in the camera's forward direction. So pretty much all we're going to do is modify this forward direction to move in or out based on that zoom. Okay, but for now, we'll just set to orthographic, and we'll be implementing both methods. So we first need to know, is our camera orthographic or is it perspective? So we can go if cam.orthographic. So if our camera is an orthographic camera, then what we can do to modify the orthographic size is just go cam.orthographic size minus equals diff times zoom rate. It'll apply the difference in magnitudes multiplied by the zoom rate into our orthographic size, so it'll zoom out when our fingers are pinching together and zoom out when our fingers are moving apart. But we also have this min-max zoom up here, and we want to implement that into the orthographic camera. And to do that, we can clamp the orthographic size. So to do that, we can go cam to orthographic size, to orthographic size equals mathf.clamp, and this pretty much clamps a value between a minimum and a maximum. So the value that we want to clamp is going to be the cam.orthographic size, and the minimum amount we want to clamp this by is going to be the min-max-zoom.x value, and the max is going to be the min-max-zoom.y. So there we are. We're clamping our orthographic size. But what if our camera is perspective? So here we can go else. So else is our camera perspective. If so, we are just going to modify our transform.position. We're going to add to that our transform.forward direction multiplied by the diff times our zoom rate, just like that. figuring out the min-max and applying that to our camera's forward direction. We could do that in a way that is simple, but that will limit us to not really being able to drag our camera, or there will be many different sort of bugs in that. But there is a more advanced way to calculate a minimum and maximum zoom for this, but it will require a bit more maths, and I reckon for now this is fine enough. If you're working with an orthographic camera, it works perfectly, and for a perspective camera, it works perfectly as well. So, back in the editor, what we want to do before we actually build the game to our device is set our min-max zoom. So, what's the minimum amount of zoom we want? So I'm going to set the camera to maybe 4, and we'll make that our minimum zoom. And for the max zoom, let's make it probably, we'll just make it 15 for now so we can show it off. Alright, we'll put that back like so. And now I can build it to my device, and I'll show you how it works when we get there. Alright, here we are. I've got the app up and running. Just like before, we can drag around, we can click to change the colors, and let's see if our zoom works. So I'll get my 2 fingers, and I'll move them in and out. And as you can see, when I push them together, we zoom out. When I push them outwards, we zoom in. And as you can see, I can't really zoom in all the way because we do have the min-max set up. So I'm in the most we can zoom in, and then I'm at the most we can zoom out now. So yeah, that is the zoom gesture set up and ready to go. I'll see you all in the next lesson.